Assalamu alaikum wa rahmatullah. This is Alajmi Suliman. Our project today about Photonic Terahertz wireless communication system under supervision Dr. Simasri. The ever-growing demand for high bandwidth wireless communication has driven explosion beyond traditional microwave and millimeter waves frequency. Terahertz waves from 1 zero point 0.1 terahertz to terahertz over a vast, large, unexplored script with the potential for ultra-fast data transmit rates. However, generation multiplicating and transmitting terahertz waves efficiently present scientific challenges. Terahertz waves is phonetic-based approach offer a provision solution for terahertz wireless communication system by leverage the well-established principle of phonetic. This is the science of light and advanced optical technique. Our research and exploring novel method for efficient terahertz wave generation and high-speed modulation, single manipulation and control, and detection and single processing. Why terahertz for communication? Using terahertz wave can lead to fast data rates and generate bandwidth. They can carry more information than traditional method, make them a game changer for wireless network. Let's explore how this can impact our daily life. So first, we must see the research problem. The problems not enough wireless distance and not enough speed or bandwidth. The first one, not enough wireless distance. Current phonetic terahertz communication systems struggle to achieve data rate comparable to established wireless technology due to limitation in modulation bandwidth and signal gradation during propagation. The research will focus on some point. First one, phonetic modulator design. The research focus will concentrate on developing novel phonetic modulator with high bandwidth capabilities. Second one, single propagation and mitigation techniques. The focus here will be on understanding and mitigating the vectors that degrade the terahertz signal during transmission. Last one, high-speed data transmit protocols. This research focus will address the design and optimization of data transmission protocols, especially specifically to read for phonetic terahertz communication. Now, let's see the theory of wireless distance in terahertz communication. Propagation loss. Terahertz frequency experience high propagation loss due to the shorter wavelength, which limits the distance over which signal can be transmitted. Atmospheric observation. Atmospheric gases, particularly water vapor, absorb terahertz wave, which scientifically reduce the effective transmitting distance. The solution techniques such as performing the use of high gain antennas and selected optimal transmit windows can help mitigate this distance limitation. The second problem, not enough speed or bandwidth. The complexity of current phonetic terahertz components and the limited availability of specialized terahertz devices hinder the widespread deployment of the technology. Let's focus to this problem. Simple field phonetic devices. This research focus will target the development of more practical and less complex phonetic devices for terahertz communication. The alternative terahertz component. The focus here will be on identifying and exploring alternatives to existing specialized terahertz component. Scalable system design and prototyping. This research focus will translate the advancement in simplified devices and alternative components into the design and development of a scalable and cost-effective phonetic terahertz communication system. The theory of speed and bandwidth in terahertz communication, the availability of bandwidths, the terahertz spectrum offer upon bandwidth which is a circle for achieving high data rate required by modern communication system. Modulation techniques. Advanced modulation seems like quartet amplitude modulated can scientifically enhance data rate by specific utilities the available bandwidths. Channel capacity. Channel capacity according to the Shannon-Hartley theorem, the capacity of a communication channel increases with bandwidth and signal to noise ratio, making terahertz communication suitable for high-speed data transfer. Now, this is a site paper which I compared with, and this project plan it takes 14 weeks, as you can see. And now let's see aims and objects to these two problems. The first one, not enough wireless distance. Our object is analyze the performance and placement for current wireless access point and routers. Optimize the configuration and positioning of existing network equipment to maximize coverage and minimize interference. The second problem, not enough speed or bandwidth. The object conduct a through assessment of the current network infrastructure to identify bottleneck and limitation, effective speed and bandwidth. Upgrade hardware components such as routers, switches, and cabling to support higher speed and greater bandwidth capacities. Implement quality of service policies to prioritize critical applications and ensure optimal allocation of network resources. Research and development. This includes investigate and developing high-speed phonetic modulators, signal progression, migration techniques, high-speed and transmit protocols, simplify phonetic devices, alternative terahertz component, and scalable system design. Theoretical analyze and modulating. The project will involve development theoretical model and understand the behavior of phonetic terahertz communication systems, include signal propagation characteristics, modulate performance, and system limitations. Device design and fabrication. The scope encompassing design and fabricating novel phonetic devices for efficient terahertz generation, modulation, detection, and filtering, potentially utilized advanced materials or integrated circuit technologies. System design and prototyping. The project will focus on designing and prototyping a complete phonetic terahertz communication system, considering scalability, cost effectiveness, and real world application requirement. Performance evaluation and characterization. The development system will be regularly evaluated to characterize their performance metric like data transmit rate, latency, signal quality, power consumption, and system functionality. Here is some paper which I looked it from a literal review. Little review on phonetic terahertz wireless communication system with research problem. Phonetic terahertz wireless communication system offer permission advancement in high-speed data transmission with low latency and scalability. Cost-effective design. This chapter reviews the extended little review on the state of the art terahertz wireless communication system, focusing on key aspects such as data transmission speed, latency, and system scalability and cost effectiveness. Not enough wireless density. Terahertz and the characteristics. Terahertz spectrum. The terahertz spectrum from 0.1 to 10 terahertz offers a vast bandwidth suitable for high-speed data transmit. Low attention terahertz waves have low propagation loss in certain materials, makes them ideal for wireless communication. Potential applications used in various applications such as high-speed communication, imaging, and sensing. Terahertz wireless communication system. System architecture integration of phonetic components such as laser source and modulators to generate and manipulate terahertz waves. High speed modulation. Advanced modulation techniques to achieve high data rates. Low latency transmission. Utility phonetic techno- technology to minimize signal processing time and transmit delays. State-of-the-art research. High data rate system research shows terahertz communication system achieve data rates up to multiple gigabytes per second over short distance. Phonetic integrate, photonic integration, and corruption of phonetic circuits and with guidance to enhance modulation bandwidth and the transmission efficiency. Challenge and future directions. Channel bandwidth utilization, efficiency utilization of terahertz spectrum for maximum data transmit. Latency reduction technique, exploration of novel signal processing algorithm and architectures to minimize latency. Not enough speed or bandwidth. Phonetic integration. Microchip phonetic utilization. Microchips phonetic technology for integration of laser source modulation and detection to reduce system size and cost. System on chip design, implementing compact and integrated phonetic system on single chip. System design optimization. Thermal management addressing terminal issue associated with high power terahertz source and modulators. Energy efficiency, deployment energy efficiency design to ensure cost effectiveness and environmental sustainability. Cost effective solution. The cost effective solution, material and fabrication techniques, advancement in materials and fabrication method to reduce the cost of a phonetic component. Modulator design approach, creating scalable and modulator designs that can be adapted for various applications. State of the art research. Integrated terahertz resources, exploration and integration laser source and modulator to reduce system size and cost. Phonetic packaging, innovative packaging techniques to reduce system footprint and improve reliability. Challenge and feature direction, scalable manufacturing, processing, developing scalable and efficient manufacturing processing for terahertz phonetic devices, system architecture innovation, exploring new system architectures that offer scalability and cost effectiveness. And now the methodology for photonic terahertz wireless communication system. First one, methodology for not enough wireless distance. Data transmit, design and implement high-speed modulate techniques to achieve data transmit rate of multiple gigabit per second, low latency transmit, minimize single process time and transmit delays, data collection, primary data, field experiments, simulates the secondary data, lecture review, industry reports, modulation techniques and single processing, advanced modulations technique, multi-level modulation, optical modulation utilization, high-speed photonic modulators, signal process, digital signal processing, low latency signal processing techniques. Eva- validation and testing, simulation testing, scenario analysis and comparing with existing solutions, and in field trials, pilot developments, and data analysis. As you can see, we can use OptiSys program as a simulator. And now the second one, methodology for what? For not enough speed or bandwidth. I do example on it. And now let's see. First is a scalable design and cost effective design. Data collection, primary data, field trials, it's well interview and surveys. Second, data letter review and industry reports. Photonics integrated techniques, microchips photonic, modulator design approach, integrated phonetic circle and packaging innovations. And now let's see example for the effective of distance on data transmit speed. This is the example. What I do in this project, I will show the effective of distance on data transmit speed. I use a component on this project on OptiSys. I use CW laser to generate the optical signal, and PRPS generator to produce a random bits sequence, and electric pulse generator to shape the electric signal, and Mazig the hinder modulator to modulate to optical single optical fiber to simulate the transmit channel. And in this optical fiber I change the distance to see the result. Optical amplifier to communicate for attenuation. Photodetector to convert the optical signal back to an electric single bits. Low pass filter to filter out noise. PER analyzer to measure the bits error rate and see after using the optical fiber with kilometers. As you can see, I change the length of the optical fiber cable from here in this cases, and see what if I make it 1 kilometer, 2 kilometer, 5 kilometer, and 10 kilometer. And this is the data rate is 50. And now we use the PER analyzer to measure and see a bit error rate. When it was the length 1 kilometer, it was 1e minus 9. You can see the result. Analyzer the result when using the PER analyzer to display the bit error rate, PER, and accessing signal quality. Repeated the simulator for different distance, adjust the length of the optical fiber for virus distance 1 kilo to 10 kilos, and repeated the simulation. And now we can see the result here after the 1 kilometer, 2 kilometer, 5 kilometer, and 10 kilometer. This is the result. And now the conclusion. In conclusion, terahertz waves offer a thrilling glimpse into the future to photonic wireless communication. With continued research and cooperation, we can ride the wave into a new area of connectivity. Thank you, and this is the reference. And thank you very much.